Okay, so here we have 55 on 10.5, and we are filled with panic, correct?
Yep. So much. Yep.
Yeah, actually, okay. This is actually panicky, right?
Yep.
Because there's like little fraction-y deals in the exponent, and
There's a lot of messed up stuff.
and there's a lot of other messed up stuff going on, right? Okay, so the deal with things like this is really just kind of, okay, I've got a fraction, right?
Right.
Everything's multiplied together. So my goal is going to be basically to group like terms, right?
Mm-hmm.
You guys see that? Okay, so let me fiddle with this stuff. So on the top, I've got 27x squared y to the 1/2 power. What do I think when I see the 1/2 power? Yeah, really, that's a square root, right? Okay, so that's this first term. I've got the square root of all the stuff, 27x squared y, right? Then this next thing I've got is the square root, right, of all of the next stuff, which is 3xy, right?
Mm-hmm.
And then on the bottom, I've got a 5. That's the first thing that doesn't panic me, right?
Mm-hmm.
Okay, so there's a straight up 5 on the bottom. I'm good with that. Then there's a x to the 1/2. What am I thinking when I see that?
Oh.
Yeah, that's just over a square root of x, right? This is just another way for me to write square root of x. That actually calms me out a little bit, right?
Mm-hmm.
And then there's a y squared. Okay, I think I can deal with y squared on the bottom, right? Okay.
Mm-hmm.
All right, so there's a couple thoughts. One of which is maybe, I don't know, maybe I'll just play with the exponents. So let me just use the exponent rules, right? Let me say, okay, this is, let's see, 27. I guess that's got a square root on it, right?
Mm-hmm.
And then there's a square root of x squared.
Oh.
Oh, I don't know. So why am I concerned about that? Yeah, because there's some halves. So maybe if I group them together, I'll be able to figure it out. Okay, so that's basically what I'm going to do. I'm just going to say, okay, I got the square root of x squared here. Let's see, then I got the square root of y. You guys all see this?
We're square rooting them because it's to the 1/2.
Yep. Yeah, really, when we see that 1/2 power, we really think, well, there's this other rule, right, that I had written over here, which is just that stuff to the 1/2 power, that's really just the square root of the stuff.
Okay, so we should make that as a note.
Yeah. That's one of the exponent rules you're going to want. The other exponent rule that I'm using here, kind of without saying it, is that if I have a, b, right, two things multiplied together and then raised to a power, that's the same thing as raising the first one to the power and then multiplying it by the second one raised to the power. You guys see that I did that?
Okay, so 1/2.
Okay, so what do I do with this second piece?
Same thing.
Same thing, right? Just square root each of the pieces. It's all multiplied together, so it's all good. So I've got square root of 3, square root of x, square root of y. Show that. All right, and then on the bottom, what have I got?
Square root of 5 and square root of x and square root of
Just 5, no?
5 square root of x times y squared.
Okay, so where's the 1/2 on, right?
On the
So it's just on the x, right? So there's a 5, there's a square root of x, and there's a y
square.
squared. Okay, so now this comes at this point comes to like, okay, group some like terms stuff, right? So what are kind of my like terms here?
Square root of x.
Why didn't I write this as y times y? You could. Go for it. Same thing. Okay. So yeah, I'm looking for canceling stuff. Okay, so some of that.
Doesn't 3 go into this one?
So which things do I know I can cancel right now? This symbol, right, root x, and root x both appear top and bottom, so that's a onesie, right? So I can cancel that thing right now,
Cancel the one.
right? That's pull a onesie out and cancel it.
Right.
Okay, then what else have I got?
2 ones?
Okay, be careful with the y's, right? Why are you being careful with the y's?
Because the bottom doesn't have a square root.
Yeah, because the bottom doesn't have a square root, so I can't straight up cancel those. They don't quite cancel themselves, but they combine at least, right?
You end up with 1 Y.
Yeah, so here I think, all right. So now this is my group-like term step. So let's see, there's numbers, right? So I'm going to group those out front. So what are the numbers here?
27, 5.
27 times 3?
There's the square root of 27. Don't forget the square root. And then there's times the square root of 3, right?
81.
That's square root of 81.
Oh, it's square root, yeah. Okay, good. It's the square root of 81, which is 9. Okay, so I'll be able to get that in the
Do
next
you have
step.
to do plus or minus 9?
When do I get the plus or minus? I know that's what you're asking. Does anybody remember when I get a plus or minus? Yeah, when I introduce the square root, I need a plus or minus. The square root by itself doesn't have it. That's to keep it a function. If it has the plus or minus, it's not a function anymore. All right, so my numbers were square root of 27, square root of 3, and then on the bottom there was a 5. Okay, so that's just me kind of grouping the numbers to the left, right?
Right.
Okay, now what else is there?
Can you multiply the 2 y's up?
Okay, so there's a root y and a root y, right?
Yeah.
So let's see. What else can I simplify first? How about the x's? How many? What's the root of x squared?
F.
Thank you.
Ta-da!
What's this called?
Absolute value.
Yeah, really, it's the absolute value of x, right? Why is it the absolute value of x?
Because it can be positive or negative.
Because I could fit a positive thing in here, right?
But that's the only case.
But, right, I want to look in the book. The book says when you simplify, right, simplifying on this problem, you can assume that the variables are positive.
Right.
Okay, so I would normally worry about the absolute value of x here, but the book said not to. Okay, so that was in the instruction. So I'm going to assume x is positive. That means I can replace this with just an x. Okay, so I've got an x, and then there's a root y. And then, let's see, there aren't any x's left on the bottom. What else is on the bottom?
Y squared.
There's a y squared. Okay, so now I want to ask myself, let's see, this stuff I know I can deal with, right? That's the square root of 81, which is 9. Then there's a 5 on the bottom. There's a y squared. There's an x on the top. And what's root y, root y?
Y.
What? No, twice.
Convince me.
What?
If you add 2 halves of something together, it's going to be
1.
You guys see what he's using? He's saying, yes, math. Exactly. Yeah, he's saying, okay, y is the 1/2 power, right? Root y is the 1/2 power. If I multiply those together, that's combining 2 halves of something.
y to the first.
So I should get y to the first out of it. The other way to think about this is to say, okay, you've got root y and you're multiplying it by itself, right? That's root y squared.
Yeah.
That's y.
Okay.
Does that make sense? You square root it, and then square it. That gives you back what you started with. Cool? As long as it was positive. All right, so I get a y. Now what can I do? Yeah, really I can say, okay, this represents 2 y's here, this represents 1, so that's a onesie. Cool. So I get 9x over 5y.
Nice.
Cool? You guys want to see another way to do this?
Yeah, it's faster.
I like that way though.
No.
Okay, so you can like this way. That's totally fine. You can do things this way if you want. It's totally fine. I'm going to show you another way. Basically because I want to play with exponents a little more, so let's get a little practice.
Is this one easier or harder than the next one?
Different. Yeah, just different.
It's faster, isn't it?
Different. All right, so